I want to show you how we calculate the pH of a solution containing a strong base. You can always identify a strong base because it has OH on it. Sodium hydroxide, barium hydroxide, this is scandium hydroxide. It can have 1, 2, 3, I think up to 6 hydroxide ions on it. Calculating the pH of a solution containing a strong base is slightly more difficult than for a strong acid, but not significantly. Here's the trick. The concentration of OH minus in your solution is simply the same as the concentration of your strong base, which I don't know what I'm going to call it here. I'll call it XOH, because I don't know what X is. Now, you have to count how many OHs each of these molecules gives you when it dissolves. This one gives us 3, this one gives us 2, this one gives us 1. Let's pick 2. For each of these strong base molecules that dissolve, we're going to get 2 OHs out, which is why we have to double the concentration. Or, for example, if it turned out that we had 0.5 moles per liter of this barium hydroxide, our concentration here would be 2 times that, or 1 mole per liter. Now, once you have the concentration of OH minus, there are several different ways you can get the pH from that. My preferred way is with something called POH, which is kind of like the opposite of pH, in that it's the negative log of the OH minus concentration. In this case, I would take the negative log of 1. I get 0. Okay, that's easy. And the way you calculate pH from POH is to subtract it from 14. Or in this case, the pH is actually 14, which seems very high, but it is the solution of a strong base, so it makes sense. Another way you can convert from this concentration of OH into pH is to calculate H plus directly from it using something called kW. I will check out my other video about what kW is, why it's important, and how it can help you in these kind of questions. But this is the simplest way. This is my preferred way. It's easy to mark, it's easy to do, and it's also my favorite way to calculate the pH of a solution containing a strong base.